Okay, so this is our last problem for the hyperbola. It's a word problem about a cooling tower. So it says the design layout of a cooling tower is shown. The tower stands 179.6 meters tall. The diameter at the top is 72 meters. I know this is blurry, so that's 72 meters. And at their closest sides, the tower are 60 meters. So we'll remember that that's 60 meters. Now, find the equation of the hyperbola that models the sides of the cooling tower. Assume that the center of the hyperbola indicated by the intersection of dashed perpendicular lines in the figure is the origin of the coordinate plane. Round final values to 4 decimal places. Okay, so here we go. The dashed lines are right here and right here. And so we're treating that as our x and y axis with the center at the origin. So we know our hyperbola is going this way. And then on the other side, this way. Whoops, this way. So it doesn't have very much of a curve to it. But we know it's opening side to side. So we know we're going to use the form x squared over a squared minus y squared over b squared equaling 1. We're centered at the origin because we're pretending this is the origin right there. Okay. Now, we know some things. The vertices are those closest points that are 60 meters apart. Well, then that means the distance between the center and one of the vertices is A, which is 30, half of, that transverse axis. So we know A is 30. If we square that, we know A squared then is 900, 30 times 30. Okay, so we know A squared. The other thing might be a little bit trickier to pull off here, but we know this point right here. This is an ordered pair that satisfies our equation, and we know the coordinates for it. If this is 72 feet here, then half of that is 36. So the x value is 36, and then we know the y value is right here, which is 79.6. They tell us that in the picture. 79.6. That is going to be an ordered pair, an x and y that we know. So we're going to fill in the a squared that we know from over here, the x and the y, and we'll know everything except b squared. Okay, so x is going to be 36, and we're going to square that over 900. Okay, minus y, which is 79.6 squared over b squared, which we don't know, equals 1. Now, I do it a little bit different than the book did. I went ahead and put in the values that I knew, and I'm going to multiply by the LCD, which is 900 b squared, and eventually I'll get a calculator to do my calculating for me. So I get 36 squared, I don't know what that is, times 900, times b squared. The 900s here are going to cancel, minus 79.6 squared times 900. The b squareds are going to cancel, and this is going to equal 900b squared. Now, if you like the way the book does it better, that's fine too. I'm not picky on that. I might run out of room though. Okay, so I want to solve for b squared, so I'm going to get my b squareds together on one side. We've done this type of thing before. And I'm going to put this term, which is just a number, on the other side. 79.6 squared times 900. Okay, so then I'm going to, on the left-hand side, I'm going to factor out b squared. It'll be 36 squared minus 900. And that's going to equal 79.6 squared times 900, like that. So what I have to do is I have to divide by that 36 squared minus 900 on both sides. So then I run to a calculator. I'm out of room here, but I'll scroll it up. So b squared is going to equal, and I'm going to go 79.6 squared times 900 divided by, and you have to open a parenthesis, 36 squared minus 900 and close that parenthesis. And when you do that, you're going to get b squared equals approximately, and we're going to go to 4 decimal places. I already did it on my calculator, but I get 14,400.3636. So you can do that on your calculator. And it said to go to 4 decimal places, so that's what I have. And now I'm going to write that equation. So x squared over, if you remember, a squared was 900. And then it's minus y squared over 14,400.3636 equals 1. And then that's going to be our answer.